I said there's basically two ways of integration, two techniques. Substitution and by parts. So let's look at this thing, integration by parts. Now, when do we use it? We use it when we're integrating, it's a product of two functions, but one is not the derivative of the other. So you can't create that derivative times function situation. Here's the formula. Integral of u to v is uv minus the integral of v to u. Let me prove it to you. There's our product rule. Write down the first, diff the second, plus write down the second, diff the first. So therefore, if I differentiate uv and get the right-hand side, if I integrate, then uv must equal the integral. It's a horrible way of writing it, I hate it, but at least it proves the formula. The integral of u to v dx plus the integral of v du dx. The dx's, if you like, cancel, and I get the integral of u to v plus the integral of v to u, rearrange some terms, and I get the formula. So basically, integration by parts is, in fact, the product rule in reverse. It's going back the other way. Things to keep in mind when we're trying it. What's u? Well, u I want to pick so that when I differentiate that particular function, it becomes simpler. dv, well, it has to be something that can be integrated, because we're going to have to work out what v is. So dv, got to integrate it, get v. So they're the sorts of things I'm looking at when I want to choose which function is going to be my u, which function is going to be my dv. So x times sine x is that situation, right? If I choose u to be x, then when I differentiate it, I get 1. Well, that's simpler. If I choose u to be sine x, when I differentiate it, I get cos x, and that's pretty much the same. Now, as far as dv goes, I can integrate both of those. So yeah, it looks like we'll go with u equals x. So if u is equal to x, then du is dx, dv is sine x, which therefore means v is minus cos x. So it was u times v, x times minus cos x gets me minus x cos x, minus the integral of v to u. So we've got minus cos x, it becomes plus the integral of cos x. And the integral of cos x is sine x. And I just moved it to the front because I like the positive at the front rather than negative. So sine x minus x cos x, plus of course a constant. Log x, now I've told you, just remember it's x log x minus x. But now let's prove it. So we choose u, so it makes the function simpler. We go, hang on, there's only one function there. Well, there's actually two functions there. One is log x, the other is simply the number 1. So choose u to make it simpler. Well, if I choose u to be equal to 1, it becomes 0. Well, I guess that's simpler. But think about this. That means dv would be log x. So all I've got to do is integrate log x, and that's the question I've got in the first place. So I'm kind of forced to making u equal log x. So u equals log x. Du gets dx over x. Is that a simpler function? Debatable. But as I say, when it comes to dv, I can't really choose log x to be dv because we don't know how to integrate it. Integrate dx, we just get x. So uv, x log x, minus the integral of v du. Well, that's nice. V du, the x's cancel, I just get dx. Integrate dx, and we get x. And there's the standard integral that I told you is a good idea to remember, because it saves you going through this parts every time you get integral of log x. So if you know it's x log x minus x, going to save you time. Let's do a definite integral. xe to the minus 7x. Choose u so it's simpler. If I choose x, differentiate it, I get 1. Well, that's certainly simpler. If I choose e to the minus 7x, well, when you differentiate an exponential, you're still going to get a multiple of e to the minus 7x. So you haven't really made it simpler, it's still the same function. So logic says we'll choose x to be u. So if u is x, the u is dx. dv then is my e to the minus 7x. When I integrate that, I get minus a 7th e to the minus 7x. Okay, uv minus a 7th xe to the minus 7x, but we now have limits here, so 0 to 1, minus the integral of v du. So minus becomes plus 1/7 the integral of e to the minus 7x. Now, whether you want to substitute in 1 and 0 to the left-hand term there now or do it later. It doesn't really matter because the limits are the same in both. So some people like to say, I'll just leave it to the end. Some people are, well, I'll do it straight away. I tend to do both. It just depends on the question. This one, I've decided to leave it to the end. So I haven't subbed into the first term yet. The second term becomes, well, we're integrating e to the minus 7x again, but now we're multiplying it by a seventh. So I get minus 1 on 49 e to the minus 7x. Now I'll sub in. So sub in 1, sub in 0, and we get this lovely answer, minus 8/49 e to the minus 7 plus 1/49. Oh, this is interesting. E to the x times cos x. Okay, we want to choose u to make the function simpler. If I let u equal e to the x, well then the u is e to the x. Not really simpler. I choose u to be cos x, then du is minus sine x. Again, not really simpler. Oh, well, let's try the other one. dv. Can it be integrated? Well, yes, I can integrate e to the x, and I can integrate cos x as well. So it doesn't really matter here which one I pick. Which one did I go with? I went with e to the x. So we'll let u equal e to the x. Du is e to the x dx. That means dv is cos x, so v becomes sine x. Okay, uv, e to the x sine x, minus the integral of v du, so minus, oh dear, e to the x sine x. I've pretty much got the same sort of integral that I started with, except it's sine instead of cos. We do integration by parts again, but here's the thing. When you have to do it a second time like this, choose the same thing. So now I will go with u equals e to the x. If I choose the other thing, I will end up in a circular argument and just get back to where I started from. So u is e to the x again. The u will be e to the x dx. The v is sine x. V is minus cos x. Okay. uv, but remember it's now minus this integral. So it's minus uv. But v is minus cos x, so it becomes plus e to the x cos x. You can see you've got to be real careful here with your signs. But then it's minus v du, but in our case it's minus, but hang on, it's also minus cos x, so it's minus, so we get minus the integral of e to the x cos x. But now, that's when we look at this and we don't see it as working out, we see it as an equation. I'll move that integral of e to the x cos x to the other side. And I now know that 2 times the integral of e to the x cos x is e to the x sine x plus e to the x cos x. Divide by 2, we have our answer. All right, so 4F, the beauty of integration by parts.